Hi, I prepared a beginner's guide to understanding artificial intelligence and large language models. This will be very easy to understand guide. Even if you're a total beginner, by the end of this video you will understand all of the basics. You'll learn about the core building blocks of AI. You'll discover how LLMs work and why are they so powerful and why is there so big hype around them. You'll see practical business applications from chatbots to customer support. You'll get introduced to advanced methods like RAG and QMR to boost reliability. You'll understand privacy concerns for businesses using AI, because this is one of our frequently asked questions. And you'll walk away with clear beginner-friendly steps to start applying AI in your business today. So let's start with the basics. Artificial intelligence is simply about machines doing tasks that normally require human intelligence. Things like problem solving, recognizing language, or making decisions. Think of AI as a really smart digital assistant. Instead of you manually doing repetitive tasks over and over again, we can set up workflows and systems so AI can do it for you. These images will make it very simple to understand. We have the user here, which is an AI developer. He needs to give instructions to AI in form of prompts, and AI will then analyze that prompt, process it, and give us the output. The output can be image, video, text, action, code, audio. The most important thing in this equation is the prompt. This is the input and what AI is getting from us. In order to get good outputs, we need to have good inputs, and that is called prompt engineering. Many people think that AI is so far ahead, but it's already everywhere. Doctors use it to detect diseases from scans. Banks use it to catch fraud the moment it happens. Recruiters use it to filter through applications. YouTube uses AI to tell you what to watch next, etc., etc. So the only thing that changed from a few years ago is that it became accessible to everyone. A few years ago, you needed to spend hundreds of thousands of dollars to develop custom solutions, and now even small teams can tap into the same power without needing hundreds of thousands or millions in funding. By 2030, AI adoption is expected to surpass 70%, with business leaders already using it to predict, automate, and optimize their workflows. So AI isn't about learning a new hyped up tool, it is about understanding your business, understanding the bottlenecks, where can we automate things, where can we use custom AI solutions to improve your business and to increase your efficiency, to save you time, and to save you money. There are many branches of AI, each solving different types of problems. We have machine learning, deep learning, computer vision, NLP, and generative AI. So it's not just about one single tool, it's a whole toolbox, and LLMs are the newest and sharpest tool in that box. They sit on the intersection of NLP and deep learning. So a language model is AI trained to understand, manipulate, and generate human language. The early versions were small, like spell checkers and autocomplete, but in 2020, OpenAI released GPT-3 with 175 billion parameters, and the world saw language models that could write essays, codes, and whole conversations just like human. So you probably use ChatGPT, Claude, Gemini, or any of other solutions, and it looks something like this. There are two reasons why LLMs are special: because of the scale and capability. They're trained on billions of words across the internet, and just because of that, they developed the skills that earlier models simply didn't have. We call these emergent properties because they weren't planned, but they appeared as the models grew bigger. So you can imagine it as a chef who memorizes the top 1000 recipes. Beyond just repeating them, the chef develops an intuition for flavors and techniques. So if you give them a mix of ingredients, they can invent a brand new dish on the spot. LLMs work the same way. They've seen so much text, they can combine knowledge in new ways and create answers they weren't directly trained on. Instead of giving ingredients, we are giving prompts. Instead of the brain filled with recipes and cooking knowledge, we have the generative model that's pre-trained with all of the information on internet plus our knowledge bases. And instead of getting a yum meal, we're getting the answer or the output that we want. Thanks to this scale, LLMs can chat naturally with you, answer complex questions, write code, essays, and stories, even adapt to new tasks that they weren't trained for. That's why many see LLMs as the closest step toward artificial general intelligence (AGI). To better understand LLMs, we need to talk about neural networks, which are based on human brain and biology. In biology, neurons receive signals, they process them and pass them along. Artificial neurons do the same. They take input, run calculations through hidden layers, and they give us outputs. And each of these connections adjusts based on training, just like our brain strengthens pathways when we learn something new. Neural networks consist of nodes, weights, and biases. Nodes are the basic processing units. They get the input, process it, and then forward it to another node. The forwarding process is done through connections called weights, which determine the strength and importance of the input signal. And we have biases that are additional parameters associated with each node that help the network learn more complex patterns. But when we set up a neural network for the first time, its weights and biases are set to random values, which means that the network's predictions are essentially random guesses. The goal of the training is to adjust these parameters so that the network's prediction align with desired outputs. Predicted output is the result generated by neural network based on its current weights and biases when given an input, and desired output is the output that we actually want to achieve. On this illustration, we can see what predicted output before training looks like. If the input is image of tiger, it doesn't give us the right response, but after training, we can adjust it so it gives us the right response. This is a very simple explanation, but for complex workflows, it's very important to understand that training is necessary. Training happens in two stages. We have forward propagation and we have back propagation. In the forward one, data flows forward and it gives us prediction. And in the back propagation, the model compares predicted output with the correct answer and it adjusts biases and weights. This training process is repeated multiple times until we start getting the outcomes that we want. In the world of language models, there are two core building blocks, and those are tokens and embeddings. If we give the input in plain English here, saying the cat jumped, the tokenizer will spread it into 4 different tokens. As a rule of thumb, each token is about 4 letters long. The token has its own ID, which is then processed through the embedding model, which gives each of the tokens its own coordinate in the vector space. So tokens by themselves are just numbers, and embedding models give those tokens the meaning. And in the vector space, words with similar meaning will be closer to each other, but we'll touch on that in a second. Tokens matter for 2 reasons: because of the cost, because API charges per token, so each time we use an LLM, we are getting charged for it, and because of the limits, because every model has a context window, which is a max number of tokens it can process at a time. And OpenAI has its own tokenizer tool that you can play around with, and you can see, for example, if I type "I like this tutorial," you can see that we have 22 characters and 5 tokens here, so it will give you a better understanding of what tokens are. There are 2 ways how AI understands text. It's lexical, that focuses on spelling and surface features. For example, bank and tank. They look similar, but meanings are different. And we have semantic, which focuses on context and interpretation. For example, the boat sailed along the bank of the river. In this sentence, the bank is referring to river edge, not finance. In the vector space, as I said, words with similar meaning end up closer together, even if they don't look alike. How are LLMs applied in the real world? Everyday capabilities like summarizing long articles, drafting emails, translating across languages, generating or debugging code, acting as chat assistants. And we also have business applications, automating repetitive tasks, which means saving time, scaling customer support, which means we can have a 24/7 customer support bot, marketing and lead gen, which can help with personalized outreach, data analysis, which will give us insights from unstructured text. Popular LLMs and their solutions are ChatGPT from OpenAI, Claude from Anthropic, Gemini from Google DeepMind, Llama from Meta, etc., etc. Now let's analyze pros and cons of using LLMs. First of all, we have summarization. It can condense long text into clear, understandable summaries. For example, lawyers can quickly review contracts without reading every line. Translation, which is self-explanatory. Content generation, we can create articles, generative videos, generative audios, code, marketing copy, etc. Conversational AI, great for chatbots, customer support. Role-playing, which adapts to personas or expert roles. Document Q&A, which finds answers from knowledge bases. Sentiment analysis, which detects tone and emotions in text. For example, hotels tracking positive and negative guest reviews. Text classification organizes text into useful categories, for example, email filters. Named entity recognition, which identifies names, places, and organizations in text. Two-shot learning, which is learning new tasks from just a few examples. And the weaknesses of LLMs are randomness, because outputs may vary, making consistency hard. Sometimes we'll get random responses that are not aligned with our input. Prompt injection, because it's vulnerable to malicious instructions bypassing safety filters. False or misleading outputs. Training data gaps and bias. Limited context, because it struggles with analyzing massive datasets in one go. Lack of common sense. Sometimes you'll get random responses, as I said, or illogical responses. Weak long-term memory. Computational demands. Outdated knowledge. No real-world interaction, which means it can't act on external systems without extra tools or API keys that we're going to use. Privacy risk, which is a big one for businesses. And latency issues if we don't set up the prompts well from the get-go. Understanding both pros and cons, the best practices are to use LLMs as co-pilots, not as replacements. Always fact-check, write clear prompts, and use examples for guidance. Now let's break down the two most commonly used frameworks, which is QMR and RAG systems. The QMR framework works with query, model, and response. It's very simple, straightforward. The query provides input and context, the model processes it, and it gives us back the response. The big problem with LLMs is that they can't know everything. Their training data is limited and static. What that means in real life: if we're developing a company knowledge chatbots, the LLM doesn't have info about our company, so we need to provide them with a knowledge base so it better understands what our company does, what is the context behind it, and it can then produce outputs that we want. And that's where RAG systems come in, which are short for Retrieval Augmented Generation Systems that connect LLMs to a vector database with semantic memory that stores external knowledge. So this is how a RAG system looks like. We have a custom chatbot application with the input in form of question. The question goes into Retriever, which will analyze the knowledge base and relevant knowledge to generate us the response. The response is then sent as an answer to us, and we can view it in our application. We also have a variation of QMR plus RAG, where we'll add the retriever in between query and the model so we can get even more accurate and context-based responses. And lastly, let's touch down on AI agents and transformers. So AI agents transform passive language models into active systems that can take action on your behalf. What that means: an LLM is the brain which understands and decides because it has our prompt here, it has the understanding of what we're trying to achieve, while tools and APIs are the hands which are executing the actions. Why it matters: because agents can schedule meetings, fetch real-time data, and automate workflows. And transformers are the engine behind LLMs, which made it possible to train very large models efficiently on massive text datasets. They have the attention mechanism, which lets the model focus on the most relevant words in a sentence. They have parallel processing, which allows them to process words simultaneously, not one by one, which makes them much faster to train. And scalability, because adding more data and parameters means better performance, which is why LLMs like GPT-4 became possible. You can think of a transformer like a team of readers. Instead of one person reading line by line, everyone will read together, which will make it much faster. Thank you so much for watching this video. I hope it was valuable. If you have any additional questions, leave them in the comments below and I'll be glad to answer. And if you want to work with me one-on-one, schedule the discovery call. Thanks again and I wish you a great day.